team. They're going to be presenting the sun bike team. Whenever you guys are ready, please start.
Hi everybody, I'm Wanga Sedikali. This is Rafael Alfonso. This is Domain Guyen. This is Ken Guyen. We're here to present you our seniors design 2 project, the sun bike. This is an innovative solar capable bicycle. Why innovative? Because most of the electrical bike out there only give you one option to charge the battery by using an electrical cable to plug into the wall. But we had an attachment to the bicycle with a solar panel to charge our bicycle with energy solar. And the solar power bicycle is right on the market. And later on the presentation, you will see why our prototype is special, because the price is very competitive and compared to other electrical bike.
Okay, so for the background, it's very competitive. Why? Because we see other bikes on the market, but the difference of those bikes, they don't use solar panel, they use electric normal, right? So this one, we use solar panel. And it's better as well because it's good for environment. And the price is less expensive than the other one. As well, it's healthy because we can turn off the bicycle, because we have a switch here, we can turn off the bicycle over there, and you can use it by pedal.
For the calculation, after I calculate is the time for the charge battery with the word at 112 volt is for like 8 hours to full battery. For the solar panel charge the battery is 8 hours to full the battery. That's why I use the 2 solar panel with the 12 voltage and with the and then universal battery for the solar panel.
And here is a diagram of how we connect all the wire electrical wire from the solar panel to the charge controller and from the battery to the charge controller.
And then for the time the battery is after I calculate for the battery, every time to recharge full battery, we can use the up to 42 minutes, and then we can ride out at 10 miles every time we full battery.
And
battery is that's why I use the 2 battery for the 12 volt each. And 10 ampere per hour.
And here is another electrical diagram on how we connect the wire from the motor to the speed controller, to the throttle grip, and from the battery to the throttle grip.
And then for the speed, with the solar panel, it's 12 volt, 2 solar panel, and then 2 battery, and then with the motor. We use at the 24 volt and then 350 watts. The speed go up to 7.59 miles per hour.
So as you can see here in the picture, right? This is what's the normal bike with a frame. Now we make the sun bike. We make a frame that's work with any bicycle as well, right? So this frame support the motor, support a battery box. Inside the battery box have 2 batteries. Have the charge controller and the speed controller. On the top of the box have 2 waterproof solar panels. As well, outside of the box, you have an outlet that you can connect to get energy from the house. As well, you have here, as you can see, we have a switch here. You can turn it off here. We have the outlet here, so we can connect the outlet here, the sun bike, the solar panel here, the motor, and the difference of this one and that one, that we remove the damper. Why? Because it can damage the frame. Before, our idea was to put 2 dampers on the side of the frame. But if we do it, the price is going to be more expensive. That's why we remove it and we put a bar here. That's where we can have a USB connector here, so we can control, we can charge any equipment. And as well, we have a dynamo here. When you using some bicycle, it's connected to the wheel, so you generate energy to the light. And one of the most important things, we have a drum here that have a visual indicator that tells you the life of the battery. You have a switch that you can control the speed of the bicycle, and you have a key to turn it off and turn it off.
And to support the model, we build the frame by carbon steel material. We choose this material because it has higher strength and strain properties. And the frame has the thickness of quite an inch and 19 inches long. And it's connected together by bolt and nuts. And otherwise, we do FEA analysis for this frame. Anytime the bike is operated, the model will lose most of the weight of the rider, so it's very important to know the maximum weight of the rider the model can work properly. So by using inventor software, we assume a rider weighs 100 pounds, 200 pounds, and 250 pounds to run this bicycle. And we have the results on the table. For the maximum weight we do with 250 pounds of the rider, the 1 meter stress is 39.28 kSI. Is very close to maximum stress of carbon material. The maximum is 40 kSI. So we recommend people weigh under 250 pounds to run this bicycle.
And then cost analysis, after I cost everything for the manufacturing, for design, and then for the packaging, is the cost for the unit is $1,662. Then if we cost for the 1,000 unit with the part we have from the third party, the cost just like $118 per unit. And for the retail value, include the marketing and profits and advertising, anything is for $700 per unit.
And for additional feature, we add to our bike a GPS tracker just in case the bike is stolen, so the bike can be trackable. And we also add a dynamo to provide energy for the light. And we had a USB output to charge any electrical device of 5 volts.
So in conclusion, we complete our goal with design, we build a prototype, we improve the design, we validate, and that's the result that we have. The sun bike, we work with the sun, the electric of the sun, and this is what our result, sun bike.
And we know our prototype is not perfect. We still have room for improvement. So therefore, we think about adding a stronger motor to improve the speed of the bike, to add a more efficient solar panel to reduce the time to charge the battery, to improve the weight distribution to balance the bike, to add a speed indicator, and also to add an air pump and a dynamo to charge the battery. And thank you guys for your attention. Now, if you have any questions, feel free to ask.
Thank you.
Yeah.
Yeah. Okay. So, good presentation overall.
So this is
Okay. So, what is the wattage of your motor? What is the wattage of your motor?
The model has 350 watts.
350 watts?
And 24 volts, and the power is 0.5 horsepower.
Okay, so 350 watts. And so, how much charging time versus how much? How long does it take to charge the batteries completely?
We have two options.
Well,
Yeah.
from solar, how long does it take to charge the batteries completely?
Just like 16 hours for the chapter, for the 2 battery.
16 hours, and how much ride time do you get for that?
So for the 10 miles, so every time
About
you charge
41
for
minutes.
10 miles, like
41
42 minutes, around like up to 42 minutes, like 10 miles.
See, because I'm just doing, I'm just trying to do some very basic rough math
Yeah.
to see if this is within the realm of the laws of physics.
Yes, I
Okay.
understand.
And what the rough math I'm using is like this, without knowing anything about your actual system. The rough math I'm using is, I know on the Earth's equator, direct sunlight is about 1,000 watts per square meter. So for a square meter of surface on the Earth, you get about 1,000 watts. And then solar panels are about 20% efficient, max.
Yeah.
So you're dealing with 200 watts max, and you have maybe a square foot of solar panel there.
Yeah.
So you're gonna get about 20 watts of that under ideal conditions. So I don't know whether that's realistic or not. I don't know whether that, I'd have to do the math to see whether that's, so if we did, let's see, 20, I'd have to do the math on that really quickly, but I mean, it might work out, throw that into a calculator, but basically for every, what's 350 over 20? So that's going to be 17. So you're gonna need to you're always at, even if everything is 100% efficient after the solar panel,
Okay.
your charge time is always going to need to be 16 or 17 and a half times your ride time, or which is it within the realm of possibility?
Yeah.
Within the realm of possibility. Okay. Okay. Just checking to see if it passed basic smell test. And it does.
We understand.
Okay.
So your FEA analysis, go back to your slide there. Your safety factors are alarmingly low. Go back one more slide.
Okay.
Okay, there. That's 250 pounds just sitting there politely, right?
Yes.
It's not
Uh-huh.
moving.
Yeah.
Do you feel that your safety factor is going to dip below 1 if a 200-pound person bounces? Do you see what I'm saying? Like, if that person jumps on that seat, I think that you're going to get a pretty good shock out of that. Do you feel that that type of motion would drag your safety factor below?
Probably,
Yeah.
probably, but
No, I think it's if like with the factor, safety factor we got it. Even though you jump on the seat, it's still safety.
What's an acceptable safety factor here?
When we try to with the 100 pound, and then we had adjustable for the weight too, around like 30 pound for the bike. This is the 100 pound. It's just for the rider.
yes.
Right.
Yeah, and then we had the amount to for the bike, include the bike, and then the battery too. So whenever we get the safety factor like that, it's just 400 pound the testing. Then we can have the 300 pound up for the safety. That's why whenever you jump it, we had somehow we had the force to apply for that one. You understand what I explained it?
Okay.
Yeah. That's why we had adjust the amount for the weight, and then somehow it's like the safety is still like safety more than we think it. That's why for the engineering design always, so we get the safety factor is always the lower than that we do. We should to do it lower than that. So later whenever we manufacture it, it's always like we can get the more than that. Yeah.
I feel a lot more comfortable if you told me that you designed that for just a 400 or 500 pound load.
Yeah, that is so far right now is maximum.
Yeah, he
it is
said
like-
that it's for
No, this for the
below-
bicycle, we recommend
below
by,
250.
Oh, those are your recommended loads?
Yeah.
Yeah, that is the maximum. The rider is weight like 250 pounds.
But you're saying at 250, there's only a factor of safety of 1.3.
Mm-hmm.
That's
Yeah.
not with any dynamic amplification though.
So for now we calculate with the safety factor, and if like we add some more power, like at least from 30 pound up to 50 pound, so we get these like a little bit lower than the
I think what you need to realize is when you hit a pothole,
Mhm.
the amount of load you get is not, it's not just a couple extra pounds.
Yeah.
You are literally doubling the amount of
Yeah,
weight
you're
that is
gonna
applied to your structure.
Yeah, you're right. That's why we try to calculate is for on the like the FEA, and then we try to test couple times, and then let's see how the safety factor is going. Now, this is just like the basics we show up for the like
And
it's
also,
some like
all these is for a flat, surface.
Okay, because I mean, a factor of safety of 1.3, I couldn't even get away with that on a building for just dead load of the stuff in a room.
Yeah, I
just sitting
understand.
still.
Yeah, I
Let alone understand.
Yeah.
a bicycle going over potholes and.
yeah. But later on, so we will like show more about the safety if we want to add more.
One good thing, I think you guys are missing the point all along. Okay? What happened with that bicycle if you take the solar section? If you take the solar section out, how much weight can that bicycle take?
So if we take out the frame,
If you take out the frame, what would be the safe working load of that bicycle?
okay, because the weight in total of the weight with the frame and everything is 65, right? So
No,
if
no,
we
no,
remove
wait
the
a
frame-
second.
if we
Let's say
remove
you
the
start
frame-
from the bicycle that you bought.
Okay.
What is the working load for that bicycle?
It's around two like 200. Say,
50,
Two.
250, I think.
yeah. So we try to test with 250.
Is your weight is the weight of that frame that is supporting the box, that is supporting the motor, actually changing the dynamics of the bicycle?
Yeah.
Yes? How come?
Uh,
If the bicycle by itself supports the 250 pounds, and you're just adding a support for the motor and the thing, from the rider point of view, you haven't actually changed the philosophy of the bike except of changing not that rim. Now you have a solid frame. So I think that what you need to convey is that they are asking you something and you're responding something else. This FEA that you guys have done is for the force that you're gonna apply on that, or is actually the force that, or the watts of that horsepower that is gonna be applied? It's
Yeah,
just,
force we
it's
apply
just
for
a
it.
matter of transmission, so the 1.3 is not a safety factor on the rider
On the rider,
side,
no.
it's on the transmission.
No, transmission.
yes, correct.
So you need to be careful on what you're trying to say. You're not changing the safety factor of the bicycle chain.
Yeah.
You're not changing it. Your is an attachment. And you
Yes.
need to be conscious of those things.
But then again, if the bicycle originally had a safe working load of 250 pounds, if you're applying a 50 additional pounds, I would say the safe work, if originally that bike could safely with margin handle 250 pounds,
Exactly.
you add 50 pounds, now that bike can only safely carry 150.
Exactly.
Not 200, 150.
That's right.
Exactly
Yeah, 'cause
right.
that's part of the rider now.
Yeah,
Yeah.
That's right.
because yes, you have that whole, you have the frame, but your tires are still the same, your spokes are still the same. In the electric, actually, I have an electric bike, and you should see the frame on it. It's a big old beefy beach cruiser thing, and it's obvious the frame has been designed from the ground up to carry the extra load.
The actual load.
So that was something I would like to see in your discussion, is saying that we recognize this frame is probably not ideal, we use this for material availability, but if you really wanted to produce this, you have to design the frame in mind, or use an oversized frame or something.
Yeah, understand.
And you need to be really specific. You need to understand first the question, second how you're gonna respond.
Yeah.
Getting back to the question from Professor Johnson first. So I think, again, we don't have time to go into the details. So I think the solar power is always a good idea. It's free, right? It's from the sun, if there's a sun there. And then, so I think the total amount of energy, you'll probably need to do a little bit more study about really how this thing really, you are not suggesting replacing the electric plug, right? So you're still going to be able to plug on the electricity.
Yes,
to
yes,
charge
correct.
up. I think, and this is like, you can save some money, or maybe in an emergency, you're out of the battery power, and then you can use the sun power, right?
Yeah.
So I think this is the additional feature for that.
Yeah.
Yeah, well, we
That's why we
mentioned.
have the dynamo.
Yeah.
That's our plan for the future, that it's gonna generate energy to the battery as well. That's our plan for the future, in case of emergency.
And also, I mentioned again the cost analysis. The cost analysis slide, can I see the slide?
Go back.
I know, you probably just, somewhat is just a number, right? But in real world, I mean, this number will be challenged again and again by the management.
Yeah.
Because I mean, if you have something, you cannot meet your objective, which is to lower the cost or increase whatever the feature you have. So this number will be heavily challenged.
Like, what we did is,
Because to me, there's a cost per prototype versus the cost mass production. You can always say, okay, 1,000 units, 10,000, how about 1 million, right? You can always getting that price down.
Yeah.
But again, be very careful when in the real world engineering design. That is something would really actually make or break it, your product introduction.
Absolutely.
So, thank you, but I know you guys try to do that. That's fine. Yeah.
Can you?
There is one thing overall though that really bothers me though. It's not about the strength. There's one minor feature on this that just as from an efficiency and engineering point of view just makes me want to pull my hair out. I'm sorry. The dynamo. The front dynamo. What is going on there?
We just want to power the light in case you to run it in the evening.
Yeah, that environment, yeah.
Do you see the issue with power conversion?
No.
You are going from solar power to battery power to mechanical, to electrical power to mechanical power, back to electrical power.
Yeah.
Why don't you just run a wire from the battery to the light?
So far right now we just like use the dynamo to make the light is on, and then in the future so we will like use the dynamo to check like directly to the battery whenever that is the backup plan. Whenever you don't have the sunlight, then whenever we cannot like plug in the wall or something.
So why don't you just plug the battery direct the light?
the
can
battery to
connect
the
dynamo to the
light. Let's say
battery.
you ride the bike and then the battery dies, so you won't have light. That's why we didn't want our light to depend on our battery. That's why we separate. We put the dynamo over there, so no matter what happens, we know we can still have light.
Yeah, and if we're using, like you said, to connect this one to the battery light is gonna be less. That's what we do.
The point being with a modern, there's a reason okay, 20 years ago you did see more of that kind of thing, but nowadays with modern LEDs and things like that, I don't think I've ever seen anyone ride a bicycle with a headlamp powered by a dynamo, because the additional weight caused by that, it's so much easier just to have a set of batteries, a separate set of AA batteries that last for months and months and months, very easily with low power LEDs. I mean, so that, I mean, it's nice from an engineering point of view, but as a practicality thing, I mean, that's putting more drag on your system every time you're pedaling it.
It might be something you want to consider for the future.
Yeah. No question. Even though I'm the advisor, I just noticed that those are things that you never see until things. When you say there was a mathematical thing that didn't match, I thought you were referring to something. I will put you in perspective. You guys can reach 7 miles an hour,
Yeah, 750.
an hour. Okay?
Yeah.
Now, your battery life is 41 minutes. Can you reach more than 7 miles? If your battery only goes for 41 minutes, you haven't reached the hour where you will make actually 7.5 miles. But actually you say that you have the ability to make 10 miles. So you're there is a mathematical incompatibility.
Yes.
I know that you guys did the calculation from some different sources, but what I'm saying is I just digested and I saw your presentation over and over again. This is the first time that I was like, wait a second, 41 minutes, you can only make, that means that in 41 minutes you have to be running at least at 12, 15 miles an hour in order to reach in those 40 minutes. So always try to look for those kind of incompatibilities because that's the truth. Any other questions?
One final design recommendation I would say, what determines the amount of power a solar panel produces?
That's we use the chart like control to,
Your question, can you repeat the
At a
question?
basic level, ignoring the controls and all the other things, just at a
Okay.
very fundamental level,
Okay.
what controls the amount of power a solar panel produces?
that's why I'm saying like we use the control like check.
Now, what control the
No,
amount of?
ignore the controller. What property of the solar panel determines what power you get?
For like the power, so we use the area.
The area is what
Yeah,
Yeah.
that's the area.
So I'm looking at that, and I think it'd be very easy to just have some solar panel, side panels
Yeah.
that fold up from the
Mhm.
sides.
Yes.
And could easily increase the effective area of that 6-fold or 7-fold or 10-fold.
Yes, correct, yeah.
And so you could just have it, you plop it up, you basically,
Yeah.
you fold them down when
Yeah.
you're not, when you're riding, you fold
Yes.
them up when you're parked, and then you could actually get way more power out of that in the same size package.
That's a good idea, but like whenever we try to design it for solar panel, we need to care about if we use the curve for the solar panel, right? Somehow the sun is not just like directly the one, the one way to get it. So that's why we try to get put the solar panel somehow can like use the sun. It can get the sun is any angle.
And to piggyback on it, well, our budget was really tight, so we wanted to use like the cheapest price as possible to build this.
Any others? Looks like thing. Thank you.
Thank you.
Thank you very much.